Alright, so now we're going to take a look at the third piece in our using midpoint and distance formula, and what we're going to use is both the distance formula and the Pythagorean theorem to find the lengths of a segment given its two endpoints. Now, with that said, we're going to make sure that we've got to go ahead and we've got to memorize these two formulas, the distance formula and the midpoint formula. So they're given to us right here, but what I want you to do is make sure you guys memorize those. First thing that I'm going to do is take my 2 points and I'm going to plot them. 2, -6. So 2 is here, -6 is down here. So I'm going to have that spot, and my other point is 5, -2. So 5, -2 is right there. And what I want to do is actually find this distance between those 2 points. I want to figure out how long that is, because that's one of the things we have to do in geometry. Now there's two techniques we're going to use. One is going to be the distance formula, the other is the Pythagorean theorem. First, we'll go ahead and use the distance formula. Now when you use the distance formula, you're going to want to go ahead and take these 2 points that they give you, and you're going to want to write one right above the other, because it's going to make some things easier for you in a little bit. Now, when you write it like this, it's going to make things much, much simpler. First thing you want to do is write down D equals. Now what you're going to do next is go ahead and take these two that you've got lined up above each other, the 5 and the 2, you're going to take those two parts, and those are going to be this piece right here in our formula. So we're going to write that 5 minus 2 squared. That's going to be that piece of our formula. Now the other piece that we're going to write is going to come from the other parts. That should be -2 right here. So I'm going to have plus -2 minus -6. And both of those pieces are going to be the y2 minus y1 right there. So those two parts that's how you're going to fill in the formula. Now when you write your formula for that, make sure you have the square root going all around the numbers you have inside of it. Now once we get to this point, the rest of it is just a lot of arithmetic. So we're going to have 5 minus 2, that gives us 3 squared, plus -2 minus 6, that's going to give us 4 squared. Now 3 squared is 9, and 4 squared is 16. When I find that sum, I get a grand total of 25. Square rooting 25, I end up with a distance of 5. So what that's telling me is the length of the piece between those two coordinates that I'm given, 2, -6, and 5, -2, that length has a distance of 5. Now the other technique that we're going to use involves the Pythagorean theorem. Now for the Pythagorean theorem, what we're going to need to do is work with our 2 points and that red line that we drew. We're going to actually go ahead and make a triangle. And we're going to go from here to here to here. We're going to make a special kind of triangle called a right triangle. Now the challenging thing here for some people is going to be make sure that you count correctly. Because if you mess up the way that you count, you're going to end up messing pieces up. Now, here's how you do the counting. So we're going to have from this point to here, that has a distance of 1, 2, 3, 4. So that distance is 4. From this corner spot right here, all the way over to the end, that's going to have a distance of 3. So I'm going to have 4 and 3. And again, I'm trying to find that distance. Now the 4 and the 3, they're going to represent the two variables, A and B. And the side that we're trying to find, that's just going to be C. So in our Pythagorean theorem formula, we're going to have C squared equals A squared plus B squared. Now C squared, I don't know what that is yet, but A, now the 3 and the 4, they can go in for either A or B, it's your choice. I'm going to go ahead and put 3 in for the A and 4 for the B. Now 3 squared is 9 plus 4 squared is 16. 9 and 16 is 25. Now, when you're at this part in your equation, to solve for C squared, so we have C squared equals 25. what you're going to do is take the square root of both sides, and in other courses besides geometry, you would actually take the positive and negative square root of both sides. But since we're dealing with distance here, the only thing that we're going to be concerned about is just a positive square root. So to find the value for c, that's going to end up giving us the positive square root of 25, and the value of c is 5. Now, that is the distance that we found before using the distance formula, and so since both values are the same, that means that I did the distance formula correctly and the Pythagorean theorem correctly. Now, a couple things to point out. Just want to highlight a few things here, how some of these formulas are related. Look at this value here and this value here. Look at the 4 as well as this 4. Those two pieces end up being the same. So that's something you want to take a look at when you're using the distance formula and when you're using the Pythagorean theorem. You want to compare those pieces. Now, if you understood this, what I want you to do is try example B on your own. If you want to go through example B together, alright, here we go. Now this time our coordinates are 2, 3, and 4, 1. So let's go ahead and plot those points. 2, 3 is going to be located here, and 4, negative 1 is going to be located down here. So again, you're going to want to find that distance between these two pieces. And it doesn't matter if you do Pythagorean theorem first or the distance formula first. Now just to keep with our other video, I'm going to go ahead and do the distance formula first. So I'm going to write 4, negative 1 above it. And then I'm going to go ahead and set up my subtracting. So 4 minus 2, 4 minus 2, plus negative 1 minus 3. I'm going to square root all of that. And again, we want to make sure that we pay attention to where those pieces come from. 4 minus 2, and then the negative 1 minus 3 come from there. Now you have to be careful when you write your distance formula. Make sure you extend the radical symbol and don't forget to add the squares. So you've got the squares there. Now, 4 minus 2 is 2, and negative 1 minus 3 gives me negative 4. So as I go through this, 2 squared is 4. Now negative 4 squared is positive 16. And 4 plus 16 is 20. Now, there's some different components that you'll be looking at here. When you get to square root of 20, you can simplify that several different ways. And it's going to depend on the situation. Now, one way you could represent your answer would be by simplifying the radical. And when you simplify the radical, square root of 20 would simplify down to 2 square roots of 5. Now, sometimes we don't want it in radical form. If you just want it as a decimal, then your decimal would end up being about 4.5. Now there's going to be one little notational thing that's a little different here. Instead of an equal sign, you're going to want to use an approximate symbol. So our distance between those 2 points is about 4.5. Now, when we go to use the Pythagorean theorem, so now we're going to go back and take a look at how long. You can draw your right triangle this way if you want, or if you'd rather, you could go ahead and draw it like this. Either way, it doesn't matter. It's totally up to you. So now this piece right here, from 4 going upwards, has a length of 1, 2, 3, 4. So that length is 4. And over here I have a length of 1, 2. That length is 2. So when I write my Pythagorean theorem, the piece that I'm trying to find, c squared equals a squared plus b squared, the piece that I'm trying to find is that length, c squared. Substituting in, it doesn't matter which one I use for a or b. I'll have 2 squared plus 4 squared. 2 squared is 4. 4 squared is 16. When I find their sum, I get 20. And again, I only want the positive square root here, so I take the square root of 20. Now, what I want to do right here is just kind of compare those two pieces that I have from before. Now here I've got square root of 20, and up here I've got the distance of square root of 20. So I know I did this correctly. And that's it. We are done with this problem. Congratulations if you got that right. If you didn't, go back and watch the video again and make any corrections you need to.